Good evening, my dear students. This is Mrs. Suhair Zaki, and we are going to start a new session for second prep students and science curriculum. Let's start our session for today. I'll continue our first lesson in our curriculum, which is the changes in the states of matter, and this is the third part of our lesson. Today, our lesson objectives, and by the end of our session, you will be able to distinguish between boiling and evaporation. Also, at the end of our session, you will be able to identify the factors affecting the rate of evaporation. At the first, let's start to explain the boiling and evaporation processes. In the boiling process, the liquid turns into vapor at a certain temperature. This temperature is called the boiling point of this liquid. For example, the boiling point of water is 100 degrees Celsius, and this means that the water begins to boil, to turn from the liquid state to the gaseous state, which is the water vapor, at 100 degrees Celsius. This is the boiling point of water, and this process is called the boiling process. At the boiling point, this is the point at which the bonds between the molecules of the liquid break down, and this allows the molecules to move more freely, so they start to leave the liquid state and move freely in the environment, in the surrounding around this liquid, turning into the gaseous state. Let's discover together what is meant by evaporation. When you leave wet clothes exposed to the air, like here in our photo, the air makes them dry without reaching to the boiling point. So if you observe the wet clothes that exposed to the air, after a while or after an hour or two, the cloth that you expose to the air will be dry. So why the cloth dry without reaching by the water in this wet clothes to the boiling point? What is the explanation of drying the cloth without reaching the boiling point of water? Let's try to explain this together to understand what is meant by evaporation. Water evaporates at temperature less than its boiling point. Let's observe these photos together. The first photo below is about the boiling process, and in the boiling process you heat the water, and the heat energy allow the molecules to gain kinetic energy and move more faster, and the intermolecular spaces will be wider, and the attraction forces decreases, so the molecules start to leave the liquid state, turning into the gaseous state, move more freely, and have a very far distances between the molecules. This is the boiling process. In the evaporation process, some molecules at the surface of our liquid start to leave the liquid by gaining some energy and turning from the liquid state to the gaseous state. And this is what happened during the evaporation process. So during evaporation, the water molecules of the surface of water evaporate without forming air bubbles, while during boiling process a lot of bubbles are formed inside the liquid during heating and turning the liquid from its state to the gaseous state. So what happens during evaporation process? Let's start to explain what makes the cloth dry without reaching to the boiling point of water. As these molecules on the surface of the liquid gain thermal energy from the surrounding medium like the air, that enables them to overcome the attractive forces of other water molecule and escape into the air and converts to the gaseous state. So some molecules from the surface of water will gain thermal energy from the surrounding, from the air, from the environment surround the wet clothes to be able to escape from the surface of water and turning from the liquid state to the gaseous state. And that is why the evaporation process takes place from the surface of the liquid, while the boiling process starts by making bubbles inside the liquid due to heating the water and turning from the liquid state to the gaseous state. While in evaporation process, only the water molecules on the surface of the liquid will gain thermal energy from the surrounding that surround the water and enables the molecules to escape and overcome the attractive forces with other water molecules inside the beaker. So the evaporation process only starts from the surface of the liquid, while the boiling process takes place in all the liquid during the boiling process. What are the factors affecting the rate of evaporation of liquids? Let's do an experiment to recognize and conclude these factors. Our activity, we will observe and study the following figures to show different cases of water evaporation under different conditions, and we will conclude the factors affecting the rate of evaporation during our activity and our observations to the following figures. Let's start by the first figure. In this figure, we see two bowls. The first one has low evaporation, and the second has high evaporation. What is the condition that affects the rate of evaporation in these two bubbles? So the first one is not affected by sun rays, while the second one is affected by sun rays, and this increases the temperature, and by increasing the temperature the rate of evaporation will increase. So we can identify the factor affecting the rate of water evaporation in our figure, and concludes that increasing the temperature increases the rate of evaporation. So our first factor is the temperature. So by increasing the temperature of the surrounding of the water, the rate of evaporation increases, and if the temperature, like in the first bowl, is decreased, the rate of evaporation also decreases. So in this figure, the first factor that affecting the rate of evaporation of the liquid is the temperature. Let's conclude together. The second factor that affect the rate of evaporation. In the first bowl, there is low rate of evaporation, and in the second, it's a high rate of evaporation. What is the difference between them? The difference between them, of course, is the surface area of the liquid. What is meant by the surface area? It's the area that exposed to the air or to the surrounding. This bowl has a very small surface area, while in the right one it has large surface area, so there are a lot of molecules can escape from this wide surface area to the environment, while the number of molecules exposed to the air in the first one is small, so there is low rate of evaporation in this bowl, and there is high rate of evaporation in the second one to the right due to increasing the surface area of the liquid. So by increasing the surface area, the rate of evaporation increases, and so there is a direct relation between the surface area of the liquid and the rate of evaporation. This means while the surface area increased, the rate of evaporation increased, and if the surface area decreases, also the rate of evaporation decreases. So the second factor that affects the rate of evaporation of the liquid is the surface area. We are continue to learn about the factors affecting the rate of evaporation of liquids, and we are going to conclude the third factor that affect rate of evaporation. We have two bowls here. The first one is exposed to high humidity, and the second one exposed to low humidity. What is meant by humidity? Humidity means the percentage of water vapor in the air. So if this percentage is high, we have high humidity, and if the percentage of water vapor in the air, we have dry weather and low humidity. The humidity, of course, affect the rate of evaporation by increasing the humidity, like in this photo. The rate of evaporation will be low, while in dry air the rate of evaporation increases, and so the relation between the humidity and rate of evaporation is inverse relation. So the third factor here is the humidity. As the humidity increases, the rate of evaporation decreases, while if the humidity is low or decreases, or we have dry weather, the rate of evaporation will be high. We still try to explain the factors affecting the rate of evaporation of liquids, and from this slide we will conclude the fourth factor that affects the rate of water evaporation. In this figure we have two bowls. The bowl at the left side has low rate of evaporation, while the bowl of the right side at the right side has high rate of evaporation. What is the difference between the two bowls? The exist of the wind, which means there are a lot of air currents that increases the rate of evaporation in this case. So the force factors that affect the rate of evaporation will be the air current. Now let's study together some cumulative knowledge and remember together these concepts. The controlled variable. What is meant by control variable? Control variable is a factor that remains constant during an experiment. In any experiment, we have a controlled variable, which is the factor that remains in our experiment constant. Like in our previous experiment, we take only a constant type of liquid, which is the water. We studied the factors that affect rate of evaporation on the water, so we cannot use a bowl of water and a bowl of oil, for example. So during the whole experiment, we study the rate of evaporation on the water as a liquid, and this is our constant factor or controlled variable during our experiment. Independent variable, the cause. Independent variable is the factor that is changed during the experiment. As during our previous experiment, we change from one factor to the other, like from the effect of the presence of sun rays to the presence, for example, for a wind. These are two different factors, so they are independent variable or different factor, and we study the change that caused by these different factors. And dependent variable, the effect, the factor that changes depending on the independent variable, and this is the last point in our cumulative knowledge according to our previous experiment. So, from our experiment, it's clear that the rate of evaporation increases when temperature increases. So the rate of evaporation, as we observed from our previous experiment, increases when temperature increases. Why? Because the kinetic energy of molecules increase, thereby increasing the number of molecules that have sufficient energy to escape from the surface of the liquid increases. So if we have high temperature, this allows the molecules to gain more kinetic energy, and the more kinetic energy the molecules gained allow them to escape easily from the surface of the liquid, turning into the gaseous state. And that is why when you expose your wet cloth during the day and allow the wet cloth to expose to sun rays, it will be dry faster than if you expose the same wet cloth during the night, because the temperature during the day is higher. So this allows a lot of molecules to gain kinetic energy and escape from the wet cloth to the surrounding. Also, from our previous experiment, the rate of evaporation increases when the surface area of the liquid exposed to air increases. So if we have wide surface area, we have a high rate of evaporation, and if we have small surface area, we will have low rate of evaporation. Why? Because the number of molecules that can gain heat energy from the surrounding medium increases and be released from the surface of the liquid. So when we have high surface area or large surface area, a lot of molecules will exposed to the surrounding, and so this allow the molecules to escape easily from the surface to the surrounding. While if you have only a small surface area, so the number of molecules exposed to the surrounding will be a very small number, and so the rate of evaporation will decrease. And this what will happen when you put, for example, some water in a plate and some water in a bottle, and keep both of them exposed to the air. The bottle, of course, opened. You will see that the rate of evaporation will be much faster. In case of the plate, the water evaporates easily due to the large surface area, while in case of the bottle, only a small surface area exposed to the surroundings, so a small number of molecules can escape, and so the rate of evaporation will be very, very low. Also, from our previous experiment, the rate of evaporation increases when the humidity decreases. So if we have dry weather, the rate of evaporation will increase, and if we have high humidity or wet weather, the rate of evaporation will decrease. And of course, we have explained that humidity means the concentration of water vapor in the air. So high humidity decreases the rate of evaporation, and that is why you feel uncomfortable if you in a hot humid air, because the low rate of evaporation of your sweat, while in case of dry air you will feel comfortable due to increasing the rate of evaporation. The fourth factor, of course, is the air current. As the air current increases, the rate of evaporation increases, because the air current help the molecules to escape from the liquid surface to the surroundings. So if there is a wind or air currents, the rate of evaporation increases, and if the air currents decreases, the rate of evaporation also decreases. Evaluate your understanding. According to your understanding to the factors affecting the rate of evaporation, explain the following. The first case, number 1, wet cloth dry faster during the day when the sun is shining than at the night. As we have explained in the previous slides, we learned that the rate of evaporation is affected by the temperature of the surrounding. So in the presence of the sun, the temperature is high and higher, of course, than the temperature at night. So why the wet cloth dry faster during the day, during the existence of the sun while it's shining, than at night? Of course, our answer will be due to increasing the temperature. So by increasing the temperature during the daytime, the rate of evaporation will be increased, and at night, during the low temperature, the rate of evaporation also will be low. The second case here, number 2, feeling uncomfortable in hot humid weather. why we feel uncomfortable in the humid weather. In uncomfortable weather, which is humid and hot weather, the rate of evaporation decreases due to the presence of high concentration of water vapor in the air. And so the rate of evaporation, our sweat, will decrease. And this makes us uncomfortable in hot, humid air. This is the reverse completely of our existence in dry weather. In dry weather, we are very comfortable because there is no humid air, there is no a lot of water vapor around us in the environment. So why we feel uncomfortable in hot, humid weather? Due to decreasing the rate of evaporation. Integration with hydrology, science of studying water. Let's study together this phenomena and process. The change of water from one state to another, such as evaporation, condensation, freezing, and melting, are fundamental processes in the water cycle in nature. What is meant by water cycle? Let's try to explain water cycle from this figure here. In the bottom of the figure, there is a lake of water. What happened to the liquid water when the liquid water exposed to the sun rays? The molecules at the surface start to gain kinetic energy, so they start to leave the surface of the water and move freely on the air, and the liquid water will change into the water vapor by the process of evaporation. The water vapor rises up in our atmosphere till it reaches to the higher layers of our atmosphere, where the temperature becomes low temperature, and this allows the condensation. The condensation process allows the water vapor to turn into water droplets and forming the clouds as water molecules start to lose energy and turns once again from the gaseous state to the liquid state, but the clouds remain in the upper layers of the atmosphere. They may be freezed if the temperature is very low, and they start to melt again, and after a while the wind carries these clouds from a place to another, and the rain will fall and turning the water again into rain and start to fall down to the lake once again. So this is the water cycle that occurs each day by evaporation, condensation, then falling of rain and returning water once again to rivers, seas and oceans. The change of water from one state to another is called water cycle, and this happens in nature every day, and this process keep the water clean and pure and allow the water to be changed from salt water, of course, to fresh water by turning the water from seas and oceans into water vapor, then to the clouds. Then the clouds carried to another regions and fall as fresh water on the top of mountains that can be accumulated and returned to the rivers and freshwater lakes. And so this is our water cycle. So water cycle, as we have explained in nature, directly affects many weather factors. From our technological application, the instant coffee. The instant coffee is named as such because it dissolves quickly in water compared to regular coffee. The instant coffee is one of our drinks that we used in our daily life, and it's famous by its dissolving very quickly in hot water compared to the regular coffee. The instant coffee is manufactured by exposing sprayed concentrated coffee extract to extremely hot dry air around 250. So this is the process by which we manufacture the instant coffee. We dry the coffee and put it in a hot dry air around 250 degrees Celsius, where the increase in the surface area of the spray droplets exposed to hot air increases the rate of evaporation and the formation of the solid instant coffee crystals that we buy from the market and used as a drink in our daily life. Now evaluate your understanding. The experiment shown in the following figure was conducted. The two bands of the balance were equal at the beginning of the experiment. The two bands holds two beakers, two similar beakers, but the first beaker contains water, liquid water. The beaker or the vessel number 1 contains ice cubes, and both vessel 1 and 2 are closed tightly, and left these two vessels for several minutes. What will happen? The pen holding the vessel 1, which contains ice, moved down, so the mass of vessel 1 increased than the mass of vessel 2. So let's explain together. At the first part of the experiment, we put the same mass of the two beakers or the two vessels, the water equal the ice in their masses. After a while or after some minutes, the band that holds the ice beaker or the ice vessel moved down, dropped down. This means that the vessel 1 that contains ice, the mass in vessel 1 increases. Why the mass in vessel 1 increases? Can you explain why the mass of vessel 1 increases? Let's see together the rest of our question. We need to explain why the pan of vessel 1 moved down. We are going to choose one of these choices. Choice A, the ice cubes in the vessel 1 melted. B, the water in the vessel 2 evaporated. C, condensation of water vapor inside the vessel 2. D, condensation of water vapor outside the vessel 1. So what will be our choice? Of course, choice A, ice cubes in vessel 1 melted, will not change the mass of ice cubes. If the ice cubes turns from solid state to the liquid state, the mass is still constant, so this will be not our choice. Choice B, the water in the vessel 2 evaporated. The water in vessel 2 cannot be evaporated because the vessel is tightly closed, so the water cannot be evaporated. So also there will be B is a wrong choice. What about C? Condensation of water vapor inside vessel 2. Condensation of water vapor inside vessel 2 cannot take place also because the vessel is tightly closed. So our choice will be D. Condensation of water vapor outside vessel 1. Due to the presence of cold ice inside the beaker, the water vapor outside the beaker will start to condense on the outer surface of the beaker or of the vessel, and this makes the mass increase in this pan and will make the pan goes down due to increasing the mass of vessel. This was our last question in our session today. See you next session inshallah. Me, Mrs. Sohair Zaki, was with you today on the Ministry of Education live stream platform. See you inshallah.